In this video, we're going to discuss molar volume. Alright, so as you know, gases are much less dense than solids or liquids, of course, but the density is going to depend on the conditions. So some things like maybe temperature, that's a T, or volume, those can affect the density. So what we're going to look in this video is something called molar volume, and it's going to be measured in liters per mole. I want you to pay attention to the units. We're also going to look at density, and it's measured in grams per liter. So think back to those units as we go to calculate some stuff here. All right, so first thing we're going to do is we are going to calculate the molar volume of neon at SATP, knowing its density. And again, those are the units of density. What do we know about neon? Well, the only thing we know is that its molar mass is about 20.2 grams per mole. Sorry, I can't write very well here. Okay, so what we're going to do is we've got a couple of numbers and we're going to rearrange them so that we can get the correct units. So let's take this 20.2 grams and let's put that over 1 mole. I'll explain why we're doing this in a second. And then what we're going to do is we're going to take that density term, we're going to flip it over like this. Now, why are we doing this? So we can cancel out our grams, because if you look, we'll be left with the units of liters per mole, which is the units of molar volume. So all we got to do is take that 20.2 and divide by the 0.815, and we should get this value of 24.8. So let's remember that number for a moment here moving forward. Similar question. This time we're looking at oxygen gas. Same conditions, SATP. Notice that our density is different. It's different because we have a different gas. The only thing we know about oxygen gas is that oxygen weighs 16. There's 2 of them, so this thing must have a molar mass of about 32. So same numbers, except for that 32, and the density changes there. So we'll cancel out our grams, and when we divide 32 by 1.29, we actually get, again, 24.8. So what's that showing? That's showing us that any gas at SATP conditions is going to be that big. So thus, the molar volume of a gas at SATP is 24.8 liters per mole. So if we had 2 moles, we'd double that number. If we had 3 moles, we'd triple it. But if we have 1 mole, we have 24.8 liters in size. Okay, let's repeat here, but this time we're going to look at STP. So again, we've got neon, and you notice our density is a little different this time. So set up the same way. We'll take the molar mass of neon, divide it by 1 mole, 1 liter over our grams. We can cancel out our grams. And when you divide, you get 24.8 liters. Okay, so let's take a look at another example. Again, we've got oxygen. This time it's at STP. Again, we've got a different density here. So let's set everything up just like that. We're going to cancel out our grams. And what we're left with is 22.4 liters per mole. Once again, we have that magic number. So our discovery here is that if we're at STP, that's in terms of volume, that's how big our gas is. So STP is 22.4 liters per mole. So if you had 1 mole, it'd be that big. If you had 2 moles, you would double it. If you had half a mole, it would be 11.2. It would be half the amount. All right, let's take a look at density here, which is the amount of mass in a certain volume. So our density is equal to our mass divided by our volume. So another way to say that would be our molar mass divided by our molar volume. So here's our formula. Density equals molar mass divided by molar volume. So let's use this in a question now. So let's determine the density of fluorine gas at STP. So our density is molar mass divided by molar volume. And we know our molar mass, or at least we could figure it out. Fluorine's 19. There's 2 of them, so that's about 38. And this value is one of the magic numbers we just came up with, 22.4. You plug those both in, you can cancel out the moles, you're left with grams per liter, and it's about 1.7 grams per liter volume. So we've discovered that when we're in STP or SATP that you know we've got these magic numbers here to work with. But the fact is that most questions aren't done at those 2 conditions, so you have to do a calculation. You have to figure out how big the molar volume is, and that's not too bad to do. All you need to do is you need to calculate your molar volume is you need to know a volume and you need to know moles. So those 2 equations are going to help us. So at an unknown set of conditions, we've got 100 grams of water vapor and it's got a volume of 20.5 liters. That's how big it is. We're going to determine the density. Before we get to density, though, we got to calculate the molar volume. If it were STP or SATP, we would know 22.4, 24.8, but we don't know it, so we're going to have to calculate it. So let's find our moles. Moles of water, 100 grams times 1 mole of water. If you go look it up, well, it's about 18 and a little bit. So we can cancel our grams of H2O out. We get 5.5 moles. Now what we can do is calculate our molar volume, because that's just our volume divided by our moles. Our volume is given in the question. We just found the moles in the last step. Divide those two out, you get your molar volume. So it's much less than the 22.4 for STP. Now we can do our density. Our molar mass divided by our molar volume. So there is our molar mass of water. There's our molar volume that we just canceled. The moles can go. And we've got our density 4.88 grams per liter.